Lesson 5.3, one of our favorite topics, graphing. We're going to be graphing radical functions. We are going to specify on square roots and cube roots. Technically, each root looks a little different. The graph is not the same on all of them. But we're going to specify specifically on looking at the square root, so when our index is 2, and the cube root. What I'm going to show to you right here is, okay, these are the basic graphs. And then if you've kind of glanced ahead, you're going to see, okay, we're talking about those transformations still. We're talking about things when we translate them, when we stretch them, when we reflect them. We're going to talk about all those pieces. But before we can do that, we have to know what the basic graph looks like. So, I don't know, maybe you have an idea of what y equals square root of x looks like. Not expecting it, but if you do, great. If not, if we don't know what a graph looks like, my encouragement is going to be suggesting a XY chart. Okay. What are some x values you want to fill into that XY chart? Zero. And I'll go back and get y values here in a moment. Okay, so we like 0 as an x value. Very rarely I don't like 0, so. What else? What? 4. I like 4 as an x value. I like 9 as an x value. Huh? No? No? I like 1 as an x value. Hey guys, what kind of values did I write down? Perfect squares, didn't I? Okay. And I think you guys were overlooking 1 as a perfect square. And especially I know some of you got your blue papers out, which is good. 1's not on that paper, but 1 is always a perfect square, a perfect cube, a perfect whatever. I just didn't put it on the paper because it's always there. Maybe I should have. But these are perfect squares. I don't want to put 2 on here because I don't want to graph the square root of 2. What is the square root of 2? Some decimal, right? I don't want to have to graph a decimal. So I pick numbers that are perfect squares. So if x is 0, and I put 0 in here, what's the square root of 0? That is 0. If I put 1 in for x, the square root of 1 is 1. If I put 4 in here, the square root of 4 is 2. And if we put 9 in here, the square root of 9 is 3. Could we keep going? What would be the next number after 9 that I would put on mine? 16, because 16 is my next perfect square, right? We could say 25. We could say 36. But I stopped at nice neat 9 because I don't want to graph past 10. I'm kind of lazy like that. Or the fact that my graph only goes to 10. Okay, so let's graph this and see what it looks like. We've got 0, 0, so we've got a point there at the origin. 1, 1, right 1, up 1. 4, 2, right 4, up 2. 9, 3, right 9, up 3. And when I connect my points, my graph looks something like that. You'll notice off to the right, I made my graph go on indefinitely. Notice at the left side, what did I do at 0, 0? I just started at 0, 0, didn't I? Is there an arrow going the other way from 0, 0? No, there's not. And that brings me back to a question I didn't ask. I didn't put any negative x values in here. Why did I not put any negative x values in there? Lucy?
You can't take the square root of a negative because it would be an imaginary number.
Yeah. Square roots of negatives, any even root actually, can we do it? No. Because a negative times a negative is a positive. A positive times a positive is a positive. There's no way to take the square root of a negative where some number times itself will be a negative unless we're talking about those imaginaries, which we're not. We're only dealing with real numbers right now. So you will notice that my graph is never going to go to the left of 0 if it's just square root of x. Okay, Prepping you for some questions, you'll see. Domain and range. What is the domain of the square root graph? And what do I mean domain? Domain is how far my graph is going left and right. It's my x values, right? When we talk domain, it's my x's. And my x's go left and right. How far left does my graph go? 0. Is it going to go past 0? No, because that's negatives. How far right does it go? Infinity. So if we write this answer in interval notation, 0 to infinity, infinities always use parenthesis. And the 0 could be a parenthesis or a bracket. What is it here? A bracket because the 0 included. 0 is included. It is a point there. And so when we talk interval notation, this is the interval from 0 to infinity. Now, the domain and range questions you see in homework are, I believe, in interval notation, and it's more of a multiple choice thing. Okay? You could also possibly see this as 0 to infinity is the same as saying x greater than or equal to 0. Okay, that's using interval or inequality. It's equivalent, but as I said, I think in the homework, everything I remember seeing was interval notation, unless they slipped an inequality in there and I overlooked it. Okay, what about range? Range is going to be what?
Y.
Huh?
Y value.
Y values. It's how far down we go and how far up we go. How far down does this graph go? Doesn't go any lower than 0, does it? Okay, and that's because we can't have negative answers. Just like you can't have negative inputs, you can't have negative outputs. So it goes as low as 0. How high does it go? Is it going to keep going up past this 3? If I put more values in, yes. It's going to keep going up. Is it going to go up to infinity? It is. It's going to take a while to go there because it's going to grow very slowly. But it is. It can go up to infinity. Infinity always uses parentheses, and again, the 0 is going to have a bracket. If you wrote it as an inequality, it would just be y greater than or equal to 0 instead. But as I said, interval notation is what I feel like I saw in the homework. So that's what I would focus on here. Okay, that's your square root graph. Technically, I'm pretty sure you saw those in Algebra 1. I don't really think that's new. However, you guys know I don't ever expect you guys to fully remember stuff. I plan to reteach it. Okay, that was square roots. Now we need to talk cube roots. So, y equals cube root of an x graph. Here's my hint. It does not look the same as a square root graph. It definitely looks different. Okay. X values you want to use. 0. I could go for 0 again. What? 1. I can go for 1.
8.
I can go for 8. What? I could go for 27, but that's going to be hard to graph because my graph only goes to 10. So 27 is legitimate, but I'm not going to write it down.
-1.
-1.
-8.
-8. Why did I put negatives on here this time? Can we take the cube root of negatives?
Oh, yeah.
We can, can't we? We can take the cube root of negatives. Because remember, it takes, when you multiply 2 of something, you're always going to get a positive. 2 positives are a positive, 2 negatives are a positive. But when you multiply 3 of something, it depends what you're multiplying. 3 positives? Yeah, that's a positive. But 3 negatives, negative times negative is positive, times another negative takes us back to negative. So remember when we're dealing with those odd roots, we can involve negatives. So, what is, let's put these values in and get our y values if you haven't already. What is the cube root of -8? Okay, cube root of 8 is 2. Because there's a negative, we say negative. Cube root of -1? -1. Cube root of 0? 0. Cube root of 1? 1. Cube root of 8? 2. So remember with your odd roots, If the number you're working with is positive, your answer's positive. If the number you're working with is negative, your answer's negative. Okay, let's graph this one and see what it looks like. Left 8, down 2. Left 1, down 1. 0, 0. Right 1, up 1. Right 8, up 2. Has a little bit of a different look here, doesn't it? I don't know if you recognize it. You guys remember the graph of y equals x cubed? The graph of y equals x cubed is this graph right there. We have that graph
Layla Baldwin,
sideways.
report to the high school office. Layla Baldwin, please report to the high school office.
Okay, so we have the y equals x cubed graph. It's sideways. Okay, and that's because x cubed and the cube root of x are inverses, which we'll talk about later in this chapter. Just like if I go back here for a moment, what's the square root of x graph look like? Half of a x squared, half of a parabola. If you think about this one, the fact that it's y equals x squared was a parabola. Well, if this was plus or minus the square root of x, it would actually be a full parabola, sideways parabola. But that's because those are inverses of each other. Okay, back to our cube root. Let's talk domain and range. Domain. X is how far left, how far right? Yeah. My graph is going infinitely left and infinitely right. So negative infinity to positive infinity. I don't really like to write infinities in my inequalities. So the other option I'll put up here is just the fact that it's going to be all real numbers. So that's going to be my or here. Okay? All real numbers, because I can take any x and put it in there. What about a range? How low do you go? And how high do you go? Yeah. Negative to positive infinity, because it's going to take a bit, but it is going lower and going higher. So domain and range are both going to be negative infinity to positive infinity, or all real numbers. Okay. Now, fun fact, and I can't remember, you have some domain and range questions in homework. I can't remember if there's any on cube root or not. There definitely is on square root, but the fun fact on cube root, it doesn't matter what I do to this graph. Whether I shrink it, compress it, reflect it, move it left or right, move it up or down. Guess what? Domain and range, they're always going to be negative infinity and positive infinity. Because that graph is always going to be going infinitely left and right and infinitely up and down. Square root graph, okay, this one's going to change depending on where that endpoint is there. So we'll have to work on that one. Okay. These graphs, you have all the information written down, yes? Because you will want to reference this as we go through notes and as you go through homework. Because I'm going to want you to kind of be familiar with the XY chart for a square root graph and a cube root graph. Now, the middle of the page, first of all, a radical function is a function of the form f of x equals a times the nth root of x minus h plus k. So it could be any root here. That's what the n stands for. But with the idea that, think back to what we've done, I don't know. I know we did chapter 1, chapter 2, I think chapter 3. I think we maybe even used this in chapter 4. But the number a out front still represents a stretch or compression. So we're still going to be talking about when you multiply a number out front, it's going to be a stretch or compression. H, the number under the radical, remember if your value is with the x in the parentheses, in the absolute value. In this case, under the radical, it's going to tell how far my graph moves horizontally. What do I mean horizontally? That is your x, and it's going to be my left or right, yes? How far I move left or right. K, the number added or subtracted at the end. So if it's at the end, away from the x, not under the radical, that's my vertical translation. Vertical translation being how far we move up and down. Okay? Now, this is probably a little bit new. However, it's using old information. This chart, you've seen this chart, right? This is what we've been using. We are using Clearback as far as chapter 1. I put up here as a reminder, so you have it again, fresh this semester. I did change the C's out to K's and H's just to be a little bit more consistent here. But remember, if the number is at the end, it's up or down, direction of the sign. What's the catch with left and right? Left and right go what I call opposite the direction of the sign. It says plus a number, we actually go left. It says minus a number, we actually go right. What do negatives do? Negatives are reflections, yes? We're going to see negatives today, and they're going to be reflections across usually the x-axis of what we're doing. But it could be the y-axis if the negative is on the x. A number out front, there's your vertical stretch or compression. We're going to be graphing some of those today. Okay? And then if the number is in the radical, doesn't even necessarily have to be divided, but if the number is in the radical, you're going to see horizontal stretch and compression. I don't have that in the notes, but I know there was like a multiple choice question or something in the homework that involved horizontal. And that was because the number was under the radical with the x. Okay? So, I'm ready to do a little graphing now. And as we start doing a little bit of graphing here, notice it says graph each function using transformations. And then, don't let me forget, identify the domain and range. As we look at A, f of x equals square root of x minus 5. Which graph is this going to look like from up above? This is going to look like the square root graph, yes? So, and what are we going to do with that square root of x graph? What? I'm not going to plug in anything. Not saying I couldn't. We're going to move it 5. In what direction did you say? I disagree with up 5, though. Right 5. Okay. This sounds a little familiar, yes? Yeah. Pulling it all together. So right here, what I see that we're going to talk about is we're going to talk about the square root of x. But this minus 5, because it is under the radical, it falls into the left or right category. Because it's minus 5, that's going to tell me to move right 5. So how I like to teach this is we'll take the square root of x graph, and then we're going to physically move that graph 5 to the right. Because otherwise we have to figure out, okay, what numbers will give me perfect squares when I subtract 5? And that's just, I don't know, that's not as fun for me. So, what I'm going to do here, not that you don't have it right up above, but I'm going to write down my square root graph. This is the square root chart. Y equals square root of x was what? 0, 0, 1, 1, 4, 2, and 9, 3. So my suggestion is that we graph those points, and we're going to take those points then, and we're going to move them 5 to the right. That's my suggestion. So, a couple different ways I can teach this. One option, lightly put in your 0, 0, 1, 1, 4, 2, and 9, 3. But what am I going to do with each of those points? Move them right 5, yes? So that means I'm going to take what was at 0, 0, And I'm going to move it over to 5, 0. I'm going to take what was at 1, 1. I'm going to move it to 6, 1. I'm going to take what was at 4, 2. I'm going to move it 5 right and put it at 9, 2. I'm going to take what was at 9, 3. I didn't plan this right, and we're going to move it right 5, yes? And so it's going to be at about 14, 3. Those new dots, those pink dots, are my final graph. So I took each point and I moved it 5 right. Should have the same shape. It just got moved 5 to the right. The other option, and I don't know how you guys personally feel about this, if you remember how I taught parabolas, the other option is I'd say take the vertex, move the vertex 5 right, yes? And then from that vertex, could you say, okay, I need a point that is over 1 up 1, over 4 up 2, and over 9 up 3? That's the other option. Now, when it comes to homework in Savas, realize they're multiple choice graphs. So it's just picking the graph that, oh yeah, that one looks like it's moved over right 5. But when it comes to what I ask you to do on paper and pencil, I'm going to have you graphing it like this, okay? I almost forgot. Not going to forget. Domain and range. Thoughts on domain on this graph? Where does my graph start? How far left does it go? It only goes over to 5 now. 5 to what? Infinity. So 5 to infinity. Infinity, I'm still using parentheses. 5 is still a bracket because the 5 point is included. You could also write that as x greater than or equal to 5 if you wanted to. If you want my or option there. And then range. What are you thinking? How low does this graph go?
0.
0. How high does it go? It keeps, as it's moving right, it keeps moving up. So this is another 0 to infinity. Infinity, of course, still uses parentheses. 0 still uses a bracket. Or if we were talking inequalities, you could say not x, but y greater than or equal to 0. Okay, questions there? That's similar to what we did with parabolas. We did that with absolute value v's. We've done that with several things throughout this year, so should be familiar. Okay, B. G of x equals negative cube root of x plus 4. Thoughts on what you see here? Okay, there's a plus 4 at the end. That plus 4 is not under the radical. So we are going to be talking up 4 at some point. That negative out front, don't overlook it. And the negative is just out front. That is a reflect, and it's a reflect across the x-axis. Now, probably seems like a silly question to ask, but I still have to ask it. What graph am I doing this to? This is the cube root graph, yes? Because I do feel like occasionally when I was looking at homework, they would throw in like, okay, cube root, cube root, cube root. Oh, let me throw in this square root with it. Like, so pay attention, make sure you're looking at the right graph. So if I look at the cube root graph, from earlier. And my cube root values, and it's not that you have to write these down, I'm just trying to make sure you guys see them. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Now, how many points do you want to put on your graph? That's a personal question. Be careful how messy this gets. Okay? Now, I think for right now, I'm going to very, very lightly put on the original dots. But then we're going to move these dots twice, because we're going to have to reflect them, and we're going to have to move them up 4. So I'm going to show you. Okay, so left 8 down 2, left 1 down 1, 0, 0, right 1 up 1, right 8 up 2. That is my very original cube root graph, yes? Now, before you start moving it, you need to reflect it. What's going to happen when I reflect this across the x-axis? Okay. Switch which way with each other?
Like, isn't it the 1, 1 will go down to, and then the -1 will go up?
Yeah. So we're going to do an up-down switch. And I had to specify because I was watching you giving motions for left-right. And yeah, now it just ended up all over by the end. But, okay, this is not, and here's the deal. If it was a left-right switch, if we were switching the left side of the graph and the right side of the graph, we'd be reflecting across the y-axis. Because this is a reflection across the x-axis, we're going to take whatever's below the x-axis flips up, whatever's above the x-axis flips down, and whatever's on the x-axis just gets to stay where it is. So this one that was 2 down is going to be 2 up. If it was 1 down, it's going to be 1 up. I'm still going to have a point at the origin. 1 up is going to now be 1 down. 2 up is now going to be 2 down. I know I'm killing some of you because I'm doing baby steps here, but I'm not losing anyone in the process, right? That's my plan. Now, what do I do to finish this up? We're going to take the green points I just made and move them where? Up 4. Could you have done this in less steps? You could. Okay, so -8, 2 is going to go up 4. -1, 1 is going to go up 4.
So would it be -8, 6 or -8, 4?
-8, 6.
Okay.
Is that not what I said, I'm guessing?
Yeah, you just said up 4.
Okay.
No, that was wrong.
Yeah, okay. So yeah, it's going to be up 4 from the 2 we were at, so it puts us at 6. This one would be at -1, 5 when we moved it up. 0, 0 just moves up to 0, 4. We're going to have a dot at 1, 3. And a dot at 8, 2. So what did we do? We took these points. I'm just writing myself a note here. We reflected. And that was reflected across the x-axis. And then we moved up 4. And by all means, take less steps when you do it. Okay? Not against that at all. Before we move on, we do need to talk about domain and range. Thoughts on the domain of this cubic graph? It goes infinitely left and infinitely right, doesn't it? Okay. So So negative infinity to infinity. Range? Same thing. It's going infinitely down, infinitely up. So negative infinity to positive infinity. Parentheses on all of those, right? Okay. I was taking it easy. I was breaking you in. Now we've got to increase our difficulty level. Are you ready for the backside? Okay. C. We're still doing the same thing. We're still graphing using our transformations. And we're still going to identify the domain and range. Don't let me forget to do that at the end. So, h of x equals negative 2 square root of x plus 3 plus 5. Okay. What pieces do we see?
We're going left 3 up 5. Or reflection. Or x-axis, negative 2.
I agree with most of what you said.
You're reflecting the x-axis, but the 2 is vertical.
I was close.
Okay. Piece by piece here, I definitely agree. The plus 3 is under the radical. That's left or right, opposite the sign. The plus 5 is at the end, outside the radical. That's up or down with the sign, so that's up 5. The negative out front. The negative is a reflection. And because that reflection is out front of everything, or because that negative is out front of everything, it is again a reflection across the x-axis. Now, I'm not 100% sure, the 2 got better, but I'm not 100% sure the 2 was ever stated correctly. What is that 2?
Vertical stretch, not compression.
There we go. I wasn't sure I ever heard the word stretch. Maybe I did, I missed it. But the 2 is going to be a vertical stretch because the number 2 itself is a number that is bigger than 1. If it's a number between 0 and 1, there is your compression. So that 2 right there is a vertical stretch. Okay. So, I'm going to save the easy stuff for last. I'm going to save the left and up for last. The compression and the reflection need to be done first. And with the reflection, I just said compression. Strike that. The reflection and the stretch need to be done first. And the reflection you already know how to do by hand, right? You take it, you flip it. Vertical stretch. Which are my vertical values, x's or y's? Y. So when we talk about a vertical stretch by a factor of 2, we are vertically stretching our y values, which means this graph is not getting any wider here, but it is getting taller. So every y value is basically vertical stretch by a factor of 2, means we're going to double it. We're going to multiply it by 2. Now, I'm going to set up a chart to show this. And when I set up this chart, I can go ahead and put the negative in there. And then we can get the reflection and the stretch done at the same time. Now, with that in mind, this is what type of graph? This is a square root graph again, yes? So I'm going to write down my original square root values of 0, 0, 1, 1, 4, 2, and 9, 3. You know where those values came from, yes? Those are the values from the front side because these are square roots. Now, here's the deal. To do a stretch or compression, you just take whatever the y value is and multiply it. Because there's a reflection here, I can just go ahead and multiply by negative 2. So I'm going to take all my y values and multiply by negative 2. Okay? And take all my y values, multiply by negative 2, and I'm going to extend my chart. And I'm going to write down what these y values are multiplied by negative 2. So 0 times negative 2 is still 0. 1 times negative 2 is negative 2. 2 times negative 2, negative 4. 3 times negative 2, negative 6. So here's the plan, guys. I'm going to take my original x values, my new y values, and I'm going to graph those. And then those are the pairs that I will then move whatever it was. Left 3, up 5. So I'm going to graph these. Okay. Then I will move left 3, up 5. Actually, you'll probably squeeze in domain and range down there if I put the up 5 there. Okay, so I'm going to graph 0, 0 stayed, 0, 0. And these are just my light dots. I'm not done. 1, 1 became 1, negative 2. 4, 2 became 4, negative 4. And 9, 3 became 9, negative 6. Can you see what we've done to the graph so far? My graph is upside down now, yes. And do you see how it's stretched? It's not quite as close to the x-axis, is it? Each of those values is times 2 farther away from the x-axis. Now, am I done? No. Take each of those points here and move them left 3, up 5. So I'm going to take, for instance, this 0, 0 point. I'm going to go left 3, up 5, right? Left 3, up 5. That's my new end point. Every point goes left 3, up 5. Left 3, up 5. Make these a little bit bigger. And left 3, up 5. So I'm counting from where my blue dots are, and those are my new pink dots. That's my final graph there. We did the reflection, the stretch by multiplying by negative 2, and then we did our movements by hand. Notice on the right side of the graph I have an arrow. The left side of the graph is just an endpoint, because that's that point that was at 0, 0. It doesn't go past that point. Now, yes, domain and range. And one other thing I wanted to say, the other option here, if you just wanted to do an XY chart to begin with, any X values you put in, you wouldn't put in perfect squares here, because I would need numbers that would be numbers plus 3 that would give me a perfect square. And that's not how I teach. I'm using the translations, but okay, domain and range real quick. Okay, guys, we got to think a little harder here. Thoughts on domain? Okay. Does it go as far left as negative 3? The x value is negative 3 there. Does it go on to infinity? Yes. Yeah, it goes on through Miss Minnick's room, yes. I mean, I guess the other option would be to say x greater than or equal to negative 3. Okay, and range. This is the one you really have to think hard on. How low does my graph go? Is it going infinitely down? Yeah, so that's going to be negative infinity to start with. We haven't had any of those. How high does my graph go? What's the highest y value we'll ever use? And that is the 5 right there, isn't it? So negative infinity to 5. Negative infinity uses parenthesis 5 uses the bracket. Or that would be y values less than or equal to positive 5. Okay, timing worked out about right. We'll pick up tomorrow and do D, and then we've got 2 other sections to practice with. Okay?